Hi, I'm Brett. I'm with Random Guys. We're a virtual band. We do 70s and 80s covers virtually. Some pretty good music. Check us out on Facebook, Random Guys Virtual Band. I play saxophone for the band, but I also do the audio and the video engineering. And I put together a series of videos on audio topics. So if you're doing audio, maybe you're doing house of worship, maybe you're doing live sound reinforcement, maybe you're doing studio recording, or you might just be at home doing your own mixing. If you're doing audio, you might find these videos helpful. So let's check out today's video. So let's talk about electrical noise. Right now you're looking at a waveform on the oscilloscope that happens to be noise. That's 60 cycle hum. It's being radiated from some device somewhere in here. It's being picked up by this oscilloscope probe. You see, as I touch it, it collects even more noise. If I touch the end of it, even more noise. This is a high impedance signal, very susceptible to picking up noise. You can see just sitting by itself, it's picking up 60 cycle hum. So that's a source of noise that's always present. No matter where you are, the power source is alternating current. That alternating current actually has the ability, if it goes to an inductor anywhere, and there are a lot of inductors in alternating current, it's going to emanate electromagnetic energy. It's going to radiate it. In this case, it's being radiated most likely from a switch that's behind me that's a dimmer switch, because there's an inductor in that dimmer switch. Inductors act as little transmitters, basically. And a lot of circuits have them. And so you can see it's present. You're usually not used to, in today's modern audio, you don't hear this much, but in the old days you used to hear it quite a bit, 60 cycle hum. So let's talk about balanced XLR. This is an SM57 microphone attached to an XLR cable. So how does XLR work? XLR has 3 pins. Those 3 pins carry the signal, but it carries it in a duplicated fashion. Across pin 3 is your negative pin, and that carries an inverted signal, 180 degrees out of phase with the original signal. Pin 2 is your positive signal. That carries the signal as it comes off the microphone, so that's uninverted. And then pin 1 is your ground. Both signals are referenced to ground. What happens is it gets inverted from the microphone, so we've got both the signal, same signal, both in phase and out of phase, being sent on pins 2 and 3 respectively down this cable, and then they come in and get converted or returned or flipped back over in phase and combined and summed together back into a single positive phase to be sent through the amplifier. So how does that work? What does that do? So what happens is the length of this cable has the tendency or the ability to pick up emanated 60 cycle or other RF or electromagnetic energy that's emanated and carry it down the cable as noise. If it gets presented to the amplifier, it goes through the amplification stages and you'll hear it in the speaker, especially the 60 cycle. But what happens is, with the phases being inverted, the noise gets induced in constant phase. So if it's going to get induced on pin 3, the same as it's going to get induced on pin 2. Those two are out of phase with each other, but the noise will be in phase with itself on both of those signals. So when they come in and one gets flipped back over and summed, you end up with the same signal you started with, but any noise that picked up and hitched a ride is going to get canceled out, because one of them's going to get, when it gets flipped in phase, it's going to get flipped in phase and now be out of phase with the noise that hitched a ride on the other pin. And so this is how XLR, it's called a balanced cable. It's how balanced cables work. So let's show you what it sounds like unbalanced. And to do that, let's talk about the components we have here. We've got the microphone, and we've got an ability to bring it in unbalanced. So this is an XLR jack going into a standard unbalanced, just picking off pin 2 basically and ignoring pin 3. That's what this is for unbalanced. We have various preamps that we have. Here's a preamp that takes an unbalanced signal in, unbalanced out. And then we have a power amplifier over here, small power amp. It's not going to blast your ears out, but it's capable of about putting out 8 watts or so. And we've got a speaker. So let's start by connecting the speaker to the power amplifier. You'll probably hear a click when I do that. Nope. A little bit. All right, let's connect the power amplifier to the input of this unbalanced preamplifier. You hear the 60 cycle hum? This is an unbalanced amplifier. It's picking up 60 cycles, sending it over to the power amp, it's getting amplified, sent to the speaker. So let's see what happens when I hook up this unbalanced XLR input. So this is the input to the preamp. Still hearing 60 cycle. Let's see when I hook up the microphone itself, unbalanced. Here it sounds a little bit different, but we've extended our reach with the 60 cycle to this entire cable, picking up noise as well. If I move the cable around, the noise pickup gets worse or better. I can grab the microphone like this, and I'm grounding it now a little bit myself so I can kill the noise. But you can see noise is getting picked up in this circuit. It's unbalanced, being carried all the way through to the amplifier. Check 1 2 check 1 2 check, test 1 2 check check check. You can hear the signal coming through the amplifier, but you also have a lot of noise with the signal. All right. Now we're going to take the unbalanced preamp out of the circuit, and we're going to come into a balanced preamp. So here is a preamp. It takes as input a balanced signal, and it flips the phases, removes all the noise. Let's plug that into the amplifier. First we'll plug the microphone in. Let's plug this in to the amplifier. Power amp. Same setup. A little bit of fuzz, but hardly any 60 cycle. See the difference? Big difference. Unbalanced versus balanced. The only difference is this is about the same output as that preamp. The only difference is this is actually canceling the noise out by taking the balanced signal in, flipping the phase over the 2 pins, combining them, summing them, and then running it through an amplification stage. Check 1 2, test 1 2, check check, hello, check 1 2, test. Much better signal quality as a result. So you can see, you're so used to, if you've used modern audio today, the noise is almost never present. They've done such a great job of removing noise, but noise is there. And there's one example of what it means to use a balanced cable versus an unbalanced cable, and how noise gets amplified as it goes through the stages. And one of the common sources of noise is just the power supplies in the house or your office, where that 60 cycle hum is being generated by just anything that's an inductive load anywhere. Some people think, oh, LEDs, they don't produce any noise, and maybe they don't. It depends. They're DC devices. They require an AC to DC conversion in order to power them, which means there has to be a power supply somewhere built into the lighting itself. And that power supply, most power supplies have inductors. So there's most likely 60 cycle emanation coming out of even LED lighting. So it might not be as bad as incandescent lighting, and definitely not as bad as fluorescent. Fluorescent has a lot of RF emanation out of those ballasts that drive those fluorescent lamps. But just be aware the noise is there, it's real, and hopefully this is a good example of how it manifests itself and why you should use balanced cables versus unbalanced.